So, question 7. A sample of pure magnesium nitrate was decomposed by heating as shown in the equation below. There it is. So, it says, gives you the mass of the magnesium nitrate, and it asks you to work out the total volume of gas that was produced. So this is a ideal gas equation question, so it's going to be PV equals nRT. I know it's an ideal gas equation question because firstly it's asking me for a volume of gas, but also it's giving me a temperature, pressure, and the gas constant, which is a bit of a giveaway. So PV nRT, let's work out what those numbers will be. So firstly we've got 100 kilopascals, so it's going to be 100,000 pascals. We've got volume, which is what we're trying to work out. N, which is number of moles of the gas. So we've got to work out from the fact we've got the mass of the magnesium nitrate, which was decomposed. So the moles of magnesium nitrate is going to equal the mass 3.74 times 10 to the minus 2 divided by the MR of magnesium nitrate, which is 148.3. You'd have to work that out, and that gives you 2.522 times 10 to the minus 4. Now the next stage is the bit that will catch people out sometimes, and it's the fact that we've got to work out total volume of gas produced. So the number of moles of gas is actually these here. It's not just the 4 or the 1, it's the total. Obviously this one is a solid, so that isn't involved in the ideal gas equation. So to work out the moles of gas, it's going to equal 2.522 times 10 to the minus 4, and it's a 2 to 5 ratio, so I'm going to divide that by 2 first and multiply it by 5. So that gives me 6.305 times 10 to the minus 4. So that's what I'm going to use as my moles. That's 6.0305 times 10 to the minus 4. The gas constant I've got is 8.31, and the temperature is 60 Celsius, but I need that in Kelvin, and that's 333 Kelvin. So now I rearrange to find volume. So V equals nRT over P, and that equals moles, which is 6.305 times 10 to the minus 4, times by R, which is 8.31, times by T, which is 333, divided by pressure, which is 100,000, and that gives you the volume in meters cubed, which is 1.745 times 10 to the minus 5 meters cubed. So to convert that into centimeters cubed, you have to multiply by 1,000,000, which is the same as multiplying by 10 to the power 6. And that gives you as your final answer 17.5 centimeters cubed. Move on to the next question. So question 8 says a student carried out an experiment to find out the mass of iron sulfate in impure sample X. And they recorded the mass of X, and the sample was dissolved in water, made it 250 centimeters cubed, and found that an excess of adamine acid solution reacted with some potassium dichromate. So this, whilst it doesn't tell you, is a redox titration. And in an earlier question, we discussed that we use E Mr. T to do a redox titration. And the first one we've got to do is E, which is to work out what the equation is. So the equation is going to be the fact that we are reacting iron 2+, which is what the iron is in the iron sulfate, and that will oxidize to make iron 3+ and an electron. And then we're using dichromate ions, which are Cr2O7 2-, and that turns into Cr3+ when it's reduced. Now to balance this one, the first thing you need to do is balance the chromiums. It's quite a common mistake to forget that, so make sure you balance the chromiums first, then balance the oxygens with water, then balance your hydrogens with H+ ions, and then balance the charge. So on this side, currently it is 12+ overall, and on this side, because of the 2 lots of chromium, it's currently 6+, so you need 6 electrons on this side to balance the charges. So therefore, you would need to multiply this top one up by 6 if you were adding together those two equations to make the overall equation, but in this case we don't need to, because we don't need the overall equation. All we need is the ratio in order to move forward. So the next step is the mass in, moles in E Mr. T. And so we need to work out what we can work out number of moles of. And we can work out number of moles of the dichromate ions, because we've got a volume and we've got a concentration. So the moles of dichromate ions equals 21.3 times 0.0150 over 1,000, and that gives you 3.195 times 10 to the minus 4. Then we need to use the next bit of E Mr. T, which is R, which is the ratio. So the ratio of dichromate ions to the iron 2 plus is 1 to 6. So the moles of iron 2 plus equals 3.195 times 10 to the minus 4 times by 6, and that gives you 1.917 times 10 to the minus 3. Then the next step is to, if you just look, we've got to, multiply up by 10, because we took 25 centimetres cubed of the 250 centimetres cubed solution. So our moles of the iron 2 plus in 250 centimetres cubed equals the 1.917 times 10 to the minus 3 times by 10, which equals 1.917 times 10 to the minus 2. This is the point where you need to go back and just read what the question's actually asking you. So the question says, use this information to calculate a value for the mass of iron sulfate with water in the sample of X. So our final step of E Mr. T is T, which stands for triangle. So we need to use the appropriate triangle, and the appropriate triangle here to work out mass would be mass equals moles times the MR, because we've got number of moles and we know the M, or we can work out the MR of this. So therefore the mass of iron sulfate dot 7 water equals 1.917 times 10 to the minus 2 times by 277.9, which is what the MR of that is, which you'd need to work out first, and that gives you 5.33 grams, which is your answer.